Okay, so for our next talk now, I would like to invite Professor Ronaldo Prati.
Thank you very much for being here. It's always a pleasure to learn a little bit more about chemistry and material science. We, Achilles and our students are from computer scientists, and we are learning a lot, but challenges are even bigger for us because we needed to learn these things before applying them. I'm not giving a general overview of our achievements in the last year. My presentation will be a little bit more technical regarding a tool we are developing for calculating some properties that are described in the literature. But I invite you guys to have a look at the poster of our students, Renato and Luis, and also the student for Marcos after during the break, the coffee break. So you can have more an idea of the applied concepts we are trying to develop in the field of material science. This is basically the machine learning pipeline. We will have the opportunity to practice a little bit in the hands-on section. And basically, the idea is that from data that you produce, molecules and so on, we need, in the current status, to translate those structures to a numerical format that we call a descriptor, and then apply a machine learning model to predict some properties. For instance, the work with Renato, we are trying to surpass this step here, and so we can learn directly from this representation. We give a graphic representation for the molecule, and we can feed it directly to a deep learning model. And this deep learning model will try to calculate this description without pre-specifying them as we are doing today. And the work of Luis is try to understand the anomalies we have when we have a learned model. So this is an overview of our work we are developing. But this particular talk is about computing those descriptors, right? How a tool we are developing to compute them. Just a joke that I saw in the morning, and I thought that's quite funny. This is a problem with applying machine learning, because we don't know things before in applying it. So here, we are trying to learn a pattern of describing the month names based on the short names. So December, November, October, and then we start to fail because we probably only see those two examples, and then generalize from that and start failing. So machine learning is a hard topic because we don't know for sure if you are doing good or not before they apply it. So it's very we need to experiment to have this idea. And the tool we are developing is related to the topic of descriptor engineering. That is a very hot topic, research topic, when we try to apply machine learning to material science. You know, we have to, this step of translating from the structure for a format that is suitable for a learning model is not easy. It requires a lot of expertise to translate the properties correctly. So several groups around the world are developing tools and new methods for this descriptor engineering. And there are some competitions around the world that has a public data set like the KM9 data set, and people around the world try to develop new ideas for this engineering these new descriptors. And the idea is that if you have good descriptions and good and sufficient data, we can build very good models after careful research experimentation. This motivated us to start developing this model descriptor. This is the name of the package that I'm planning to release in the next months. That is has been implemented using the R programming language for computing descriptors from the molecules. And the idea is to have a very flexible, extensible, and based on core R functions for flexibility and easy development. Well, a question that I have to answer several times is, why another package? We have several packages around there. In the hands-on on Tuesday, we will be able to try some of them. So why another one? Why a new one? From our perspective, re-implementing those descriptors gives us the opportunity to understand them so we can explore machine learning models better. You know, if we understand what lies beneath, what are those methods computing, we can have a better understanding of them and then try to maximize the modeling step. It helps playing around with new ideas. For instance, in a meeting with Jonathan, he gave the idea of trying to put some penalty function or try to disconsider the influence of atoms which are very large apart from each other. Trying to implement these in these kind of ideas in third-party methods could be very difficult because you have to get into the code and try to understand. So having our own method may help us to play around with new ideas. It opens the opportunity to use a different set of tools outside the Python ecosystem. I do like Python. I do work with Python quite often. But in this data science community, there is those two main languages, Python and R. And there are a set of tools that are only available for R. So we open the box and can use another tools. And it also provides flexibility because we can combine different techniques with more easily with a consistent interface. Another reason is that those packages that are available outside, even though those more used may have bugs. And this, for instance, is a bug report that I did using one of the most used packages, the MolML. and they have errors in very simple methods. So implementing them may help. I'm comparing their implementation with my implementation, and I was able to find these bugs. Very quickly, what is R? R is a programming language and open source environment for statistical computing. It's very focused, unlikely Python, it's very focused on data tasks. And it is widely used among statisticians. If you talk with statisticians, Renato is a statistician and he likes to work with R. They prefer to use R instead of Python. It runs on many OS and on the cloud. It has a very active package system with more than 15,000 contributed packages that you can download and use free of charge, and with another qualities. Why not Python? Well, because there are many Python packages already available, and we decided to implement in R, like I said, to open the box, to be able to use tools that are only available for the R ecosystem. The graph is not good, but basically says that 75% of people that uses R only uses R, and 95% that people that uses Python only uses Python. So there are things that are only available to one of those systems. Having a tool for computing descriptors for this ecosystem, open the box for playing with them. The package is quite flexible. We can input data using this CDKU format, because we have in the R a package that can reads data from this format. It uses built-in functions that are quite common in those descriptors, like computing densities, computing norms. Those built-in functions are very flexible. For instance, I was talking to the guys in the morning. One of these packages that implemented a descriptor in Python they have to implement a density estimator, and their code is like 200 lines of code, and they can do this in R with one line of code with several other parameters that can be explored in the future, and it's extensible. So far, we have implemented 4 state-of-the-art methods. The first one, Colby matrix, it's quite simple and straightforward to implement, but the other 3 are quite tricky, and they are among the methods that produce IG quality models, and are being published in several recent papers as model descriptors for building predictors. The next steps, as you have this flexibility, I'm thinking in implementing some kind of method that can be used to automatically set some parameters of those descriptors, so the user does not need to pre-specify them. Also implementing some methods that can merge different descriptors or combine different descriptors, producing a multi-vision of the data and release this package as an open source package. That's it.
So we now open for questions. So anyone? No? Okay. So Professor, something about that I wanted to ask before as well. Have you ever heard about the Catalysis Hub data set, which is like a data set like with several, I think, thousand of data about DFT calculations for catalysis from the Stanford
No, I
University?
don't know.
So yeah, well, like I'd like to then talk more with you about that because it might
Yeah,
help you guys.
we do need different data sets to test ideas because, you know, as the Juarez's question, maybe this data set we are playing may not be the right one for testing some ideas, and having more data is always a very good idea.
I would like to know about the possibility of employ the R functions from Python.
Yep, it is possible, but it's not that easy because internally they represent data in a different way, and you have to do some kind of internal translator. So there is the overhead of doing this translator, and sometimes this translator is not straightforward. You need to go inside the data structures and try to map from one type to another type. Yeah, it becomes easier, but it's still not a very easy thing to do.
Okay, so if we don't have any more questions, I'd like to thank Professor Ronaldo again.